Hello everyone, Doug Simonian over at New York Metro Weather with your latest video discussion. We're going to be talking about the upcoming snow for Monday night into Tuesday. For most of the New York City metro region, there shouldn't be too big of a snowfall. However, for areas east of New York City, we're still going to have to watch out for the potential for some plowable snow, maybe even some significant snow in some spots, particularly as you head out towards Suffolk County. Because the storm, it's a very volatile setup to the point where only a very small change in the configuration of the upper levels of the atmosphere could lead to a vastly different result at the surface. And we're going to be elaborating more on that and the general evolution of the storm throughout the video. So I don't have time to take a look at every model. This video is going to be long enough as it is. So I'm mainly going to be looking at the 6Z NAM model for the majority of this video, and this is at 500 millibars, so the middle of the atmosphere. We see the two main pieces of energy involved: the southern stream shortwave that is pretty strong and amplified and actually closed off in the Tennessee Valley, and then a northern stream disturbance, or polar shortwave, coming down out of Canada and dropping southward through the Great Lakes, and these two will try to interact as a strong storm system develops on the leading edge of the southern stream wave. The cleaner the interaction, generally speaking, the more in the way you can expand heavy precipitation from off the ocean into the area, but a messier interaction that's more separate, where the southern stream gets left behind and most of the heavy precipitation gets left out to sea. Now, it's a fine line because although you want for a snow perspective, you'd prefer the northern stream to dive southward quickly and try to capture and phase with the southern stream. However, if it's diving down southward too quickly, the southern stream is not going to be able to gain latitude before the interaction occurs. It's still important for the southern stream to be able to amplify the flow out ahead of it, in order to allow precipitation to stream northward before the interaction occurs. Why? Because this isn't the most friendly trajectory and orientation of a polar shortwave to phase with. Look how wide and broad its flow is. It's not just this one tight trough. It's a broad flow that's actually, from a longitudinal perspective, longer than our shortwave is. So naturally, these two are not going to phase that easily. It's going to take a bit of a longer time until the southern shortwave can really open up and kind of let the core of the northern stream get further southeast. But by the time that happens, the southern stream shortwave is already sheared out and out to sea. So it's that facet is why it's very unlikely that this becomes a major snowstorm for much of the area. However, there are still some intricate processes that could occur that could make this a significant snow for areas east of New York City, and one of them is the model volatility. This was the 6Z run, valid 12 hours from now, so this goes to 2 p.m. This afternoon. But look at the 0Z run, valid for the same time. The southern stream shortwave was clearly further south and more separated from the northern stream flow. So the models, even in the short lead time, it's only a 12-hour forecast, are still making big adjustments to the pattern. And in a setup that's so volatile, these big adjustments can make a difference between 2 inches in Nassau County and 8 inches. Or in Suffolk County, it could be the difference between 4 inches and 12 inches. Or even New York City could still be in the game for plowable snow, and coastal New Jersey as well. So with that type of trend in a short period of time, let's say the 12Z NAM later this morning comes out and shows that same incremental change. Yeah, it doesn't look like the largest change in the world, but one more bump northward, and you're able to stream more moisture northward and more directly phase with the northern stream at the same time. So it's a kind of a domino effect, so to speak. But either way, just on this run verbatim, the progression goes as such where during the initial phasing process, the southern stream shortwave, although it is initially amplified and you're setting vorticity up the coast, and you are setting southwest flow up the coast too, so moisture is getting sent, but because of the poor trajectory and angular momentum of this polar piece, the southern shortwave gets sheared out and sent eastward during the initial capture. It isn't until during the overnight, 2 a.m., 3 a.m. Tuesday, where we really start to see the actual capture and the turn northwest take place. But at that point, look how compressed the flow is over in New Jersey. It's going to be hard to get banding to pivot over New Jersey in that area, but east of New York City, the flow is slower and it's a little bit more backed in from southeast to northwest, so you can get banding trying to pivot in, particularly in Suffolk County and in New England. But just again to show you the model volatility, look what the 0Z run did at the same time. It was much further northeast. Now it's buckling to the southwest more. Additionally, on the 0Z run, the northern stream compressing flow was further east, so the banding got shunted further east. On the 6Z run, that's further southwest, so it allows more room for the banding to come a little bit further to the west on this NAM model run verbatim. And actually, it becomes a very impressive system that does phase, but again, look how much longitude the storm loses during the phase because of the poor angular momentum. It gets kind of sheared out to the east even during the phase and capture. Yes, but the wind barbs are still, backing in from the southeast and the northwest, so you are going to be able to pivot banding into eastern Long Island and New England, and maybe a western fringe band can get into Nassau County, Queens, New York City, eastern New Jersey, maybe, but nothing further west than that with this type of upper level configuration. Let's take a look at the 3 kilometer NAM. This is the high resolution NAM, just the surface. We can look at the the rain, snow. We see that with the initial northern stream energy coming down, you get vorticity advection out ahead of it, and thus an area of light snow across eastern PA, northwest Jersey, and New York. This is later this evening into the early part of the overnight. And then as the coastal system tries to work its way up the coast, we get some light to moderate snow clipping Long Island and but more so offshore at 2 a.m. And then slowly that is able to pivot to the northwest thanks to that phase and capture. Remember, we showed you with the wind barbs, or at 500 millibars, are oriented from southeast to northwest, so able to advect mid-level moisture in that direction as well. That helps to pivot the snow northwest, and also that phasing and that capture we do get allows some of the pivoting to the northwest. Yes, it gets kicked to the east initially, but see that turn to the northwest that tries to occur is able to pivot some of the banding. So we see that on the surface map, and so some light to moderate snow moves into a good portion of the area, but the heaviest of the snow stays in eastern Suffolk and especially southeast New England. They could get a pretty crushing blizzard with this storm, and these types of late capturing storms are a classic for hammering southern New England, but not necessarily hammering areas southwest of New York City. So still, yeah, I mean, nice little snow event on the 3 kilometer NAM run. Most of Long Island on this run gets, Nassau County gets 3 to 6 inches, and then Suffolk County actually gets 6 to 8, maybe locally higher amounts. The northern fork of Suffolk, and in New England there's a all-out blizzard in some areas, but then there's a sharp cutoff to the west and southwest from there because of the compression involved with that phase as well. But however, of course, that compression, because what happens is when you get the compressed flow, the wind barbs collide. We'll actually see that a little bit better in some other future plots that I'll show you, but when the flow is backing in from the southeast and the northwest, or at least when it's trying to, it's colliding, so to speak, with the incoming lowering heights and a different wind direction aloft. So you get a little bit of a convergence effect when the streams try to phase. So that converging could lead to a narrow area of a western band getting extended, and this will be better illustrated with the 700 millibar frontogenesis plots from the 3 kilometer NAM model run. We see that the main area of warm air advection and frontogenesis is off the coast of New England, where the main, look at the 700 millibar jet, the winds are very strong. Closer to our area, the wind flow is weaker. But as a storm develops and as that jet starts to wrap around the over the top of the circulation and from a northeast to southwest perspective, see, the wind flow is very weak, so there's not much temperature advection going on in our area verbatim. However, from New England, the wind barbs are getting stronger and they are pivoting towards that area of weak winds. So you're able to quickly advect warm air aloft from the ocean. You're advecting warm air aloft into an area where not much advection is going on. So that means you're tightening that temperature gradient over that area, and thus a good area of frontogenesis. This is actually a pretty strong signal for a western frontogenesis band of moderate to maybe even heavy snow across lots of Long Island, maybe even backing into New York City Tuesday morning for the Tuesday morning commute. So that frontogenesis signal does fade as the main band kind of takes over to the east in Long Island and southeast New England. So it may only be kind of a quick hitting heavier band, but the signal is there for a frontogenically driven heavy band of snow from that compression. You see with that, again, with the wind flow, the faster winds with the warm air advecting into an area where there's weak winds and not much movement of an air mass. So a good source of warm air advection and a tightening of the temperature gradient, and thus an area of frontogenesis well to the west of the main circulation. That tends to happen with a lot of these setups. You get the main band with the core of the storm to the east, and then some subsidence to the west, and then maybe one more fringe band, if not as heavy snow, of course. We're not getting a blizzard in western Long Island or New York City, but there could be a period of moderate snow, maybe even briefly heavy, on Tuesday morning with that band of snow. But again, that signal fades pretty quickly as the main band to the east just becomes too powerful. But some light snow can linger throughout the rest of Tuesday morning. We're gonna now just finish off the video for the next few minutes talking about the observations and again more volatility, and trying to compare any of the volatile solutions with the observation to see what's noise and what is still valid. This was the European model. The 12 is the European model, valid for 2 a.m. Tuesday morning. There's no interaction really at all. The southern shortwave gets very sheared out, and it's just heading north-northeast. There's nowhere to go. There's no mechanism to back it into the northwest. But on last night's European model, about for the same time, look at that difference. The southern stream is captured. It's actually partially phasing. The compressed flow is backed into the southwest. You're actually able to get some precipitation advecting in from the southeast to the northwest. It's a much more favorable solution if you're looking for snow. And then again, 6 hours later, we've almost completed the phase on the European model. The close 500 millibar low, look at the previous run, was way out, was way sheared out, and like incoherent circulation. So the fact that we got that type of a shift in such a within a short time period shows that there is still room for a movement towards the snowier scenarios. My analogy is that usually within 1 or 2 days of a storm, you don't get that much model chaos, but with the setup this volatile, the models 1 to 2 days are really going to have the chaos as if the storm were 3 to 4 days away. Thus, some shifts can still happen. However, for the rest of this video, I'm going to try to eliminate some of the outlier solutions that we are seeing. This is the current observations actually. At 500 millibars, valid for 5 a.m. And we see the the southern shortwave and the Tennessee Valley and the northern shortwave. And we can just look at the general configuration of the heights. On the NAM model, let's go back to the NAM model and see what it had for 9Z. Looks pretty good, right? So I think the NAM is a pretty good simulation. It's very reasonable that its solution thus could be correct, where you get moderate snows into Long Island, heavy snows into eastern Suffolk and most of New England, and just light snows further to the west. I think that's reasonable based on the observations. But there is something that snow lovers like to hang on to, is the SREF, the Short Range Ensemble Forecast. It pretty much takes an ensemble of the mesoscale models and comes up with a bunch of different theoretical solutions based on a slightly different physics to each individual model, but that are meant to simulate all possibilities. So we can look at, now this is valid for 9Z, the mean of the solutions. Yeah, the mean of the solutions looks like the observations that we have. It looks like a pretty good match. Now, here we can look at the precipitation on some of these members. The ARW1, it's kind of more like the general scenario that makes sense, where the heavy snow stays out in Suffolk, right, and New England gets hit with the blizzard, and then the amounts gradually decrease as you head to the west, but still a moderate snow event for Nassau County, and then less further to the southwest. How was its depiction valid for 9Z? I'm sorry for these pictures being small. It's just hard to get a better simulation on this ref. This looks pretty accurate to me. This looks very reasonable, so I think the ARW1 could be on the right track. Look at some of the snowier solutions and see if any of them initialized correctly, because if they did, then maybe they still have a clue. But this is the ARW5. It's verbatim, it actually would be a blizzard for New York City and Long Island, even parts of New Jersey. Let's see if it had the right idea with the 9Z depiction. To me, this doesn't look right. It looks like it's having the Tennessee Valley shortwave too far north. So I don't think it has the right idea, and thus I think its solution can be discarded. See, in reality, the southern shortwave is a little more backed up to the southwest, so it's not able to advect moisture as far northward as you'd like it for a snow perspective. This one, it just looks a little bit too far north to me, so I don't think it makes sense. And that was the problem with a lot of these solutions that were snowier or were higher in precipitation. They just didn't seem to have a good depiction of the middle of the atmosphere. Let's look at this another one, the NMB9 member. That's obviously a huge hit based on this precipitation. Let's see how it did with that initialization, well, valid for 9Z. NMB9. See, that's too far northeast to me, and this shortwave up top looks too far to the southwest, and this kink in the heights doesn't look too far to the east enough. But still, the southern shortwave, it's clearly more opened up and involved with the northern stream already than what is the actual depiction. Yeah, it's not a huge difference, but certainly enough of a difference to where there's a reason why this is a much snowier solution, and I just don't think it makes sense based on what we currently see in the middle of the atmosphere. So these big outlier solutions on the SREF that are showing 1 to 2 foot plus blizzards, I think can be discarded. But how about the ones that are just somewhat snowy, or ones that bring like a widespread winter storm warning for a good chunk of the area? Let's see if some of those initialized any better. Let's look at the ARW12. See, it has the sharp gradient where northeast New Jersey it gets a little more snow than modeled, but still only a light event. But southeast New Jersey into New York City and eastward, you get a heavy snow event. Not a crippling snow event, but a heavy snow event, especially in Long Island. So this would be snowier than forecast. Let's see how it did with its initialization for valid for 9Z. It was the ARW12, right? So see that it doesn't look too. It looks pretty good. it's a solution that kind of makes sense for its 9Z depiction. It's not too far off. So I think the ARW12 solution is the upper bound. See, it has that kink correctly to the northern stream. It's hung back a little bit further to the southwest in Tennessee, and the northern stream, the northern part of the vort only gets up to southern Kentucky. So it's actually not too far off. So I think this theoretically could be on the right track too. So I think the ARW12 scenario is probably the ceiling, but I think something more like the ARW9, where Nassau County gets, advisory borderline winter storm warning snows, and east gets heavier snow, or the ARW1 is probably more accurate, but again, we can't rule out the idea of a heavier snow scenario, especially on the coast, because of the small tweaks that are needed, and the fact that we are still getting pretty big tweaks on the models in short time period forecasts. So the fact that they're changing so much within a 24-hour forecast shows that there is room for more changes, and since we don't need a big change for the coastal areas to get a heavier snow event, it thus can theoretically still occur. Alright, so I hope this video was informative and explained the uncertainties and the possibilities, while also making clear that our forecasts and expectations right now are still, on the moderate end of the snow impact scenarios, lighter for the west and moderate for, maybe eastern New York City and Long Island, and heavier in Suffolk County and New England. So we hope you have a great Monday, and we'll keep you updated regarding the storm's progression. Have a great day.